Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist and all-around evil scientist, DT from WX Risk here in Central Virginia, talking about This Week in Weather. I'm your Colonel of Catastrophe, the Commander of Confusion, and the Captain of Chaos. So let's talk about lots of weather here. We'll start out with a picture of my smiling face from Richmond, Virginia. And that's how there's the Twitter page and there's the Facebook page. And the new website's coming online soon, actually. We're going to have a redesigned website, so we'll see. All right, first we'll start out with some basic stuff here. Temperatures over the last 2 weeks. Actually, this is precipitation departure from normal. And the reason I point this out is if you recall, May and June was actually quite wet across much of the middle Atlantic states, and New England and Pennsylvania, New York State was actually quite dry. So here we are in the last 2 weeks, and you can see that for most of Virginia, North Carolina, West Virginia, Ohio, Kentucky, Tennessee, um, into Georgia, rainfall has actually been 1 to 2 inches below normal. Now in northeast Pennsylvania, New Jersey, New York State, northern New England, the rainfall has actually been pretty good, anywhere from 1 to as much as 3 or 4 inches above normal in a few isolated locations. Percentage of normals, you can see that over the last 2 weeks. Relative to normal, pretty good rains here, Pennsylvania, New York State, New Jersey, up into western and central New York State. Really dry, though, in the lower middle Atlantic here, essentially from the Pennsylvania Turnpike southward, really, into Georgia and out to Ohio. And you can see again, this is a departure from normal here. The temperatures, it's been pretty warm the last 2 weeks. Obviously, I don't have to tell you that. But as we continue to rack up these 95-degree days, these numbers are going to increase in terms of the departure above normal by the time we get to the end of the month. Now, typically, we average way up there near 35, 40 degrees, 90-degree days, 35 to 40 of those. But so far, many places in central Virginia, Maryland, Delaware, North Carolina, where you're not in the mountains, we've had a lot of days where we've got 25, 28, uh, 90-degree days already. And we still have the rest of January to go through here, the last 7 to 8 days of that, and then all of August, and probably into September. So it's running to be a pretty hot summer so far, no doubt about that. All right, let's take a look at overall pattern. Now, this here is our GFS. We'll use that just to show you our initial conditions. And we have our trough here on the west coast, right here, very deep trough here. And then another one, a shallow one here, which is driving a cold front, trying to get south into Virginia and down to Kentucky. And then in between here, this here is our ridge right in here, a little squiggly line, which is the weather synoptic symbol used to show a ridge. So there it is. So trough here, ridge over the plains into south central Canada. And next slide here will show us, this is what it looks like now for Friday night and Saturday morning. And not much has changed, but this feature here is a dome. That's a heat dome. It's like the top of a mountain. That's really what it is. It's so if you can imagine a mountain range and then the peak, that's where the dome is. And obviously that's where the hottest temperatures are because you're getting maximum subsidence there, and that's where you have no clouds and lots of sunshine. And it's late July, and the sun is very strong. So we can see a lot of reasons why temperatures there could get quite hot. We still have a trough here in the Pacific Northwest down to California, and another one over New England. But this trough here is kind of leaving, and as it leaves, this dome is kind of expand a little bit into the northeast, the mid-Atlantic states, and that's going to send temperatures soaring again, unfortunately, and we'll see that in just a minute. Now, right here, this is the Thursday afternoon, Thursday evening weather map. You can see our two cold fronts here across the Ohio Valley, then to Pennsylvania, New York State, New England, and then pretty good rainstorms here, thunderstorms in the western half of Virginia, up into the DC area again. Not so much in central and eastern Virginia, not yet. And then western North Carolina. That'll probably happen on Friday, I think. All right, slide here. Oh, this is our next short-term forecast, and you can see what happens is, with this trough trying to drive the cold front southward here and here, we see the cold front at the surface on these images from the GFS. So this is early Friday morning. You can see the cold front trying to push southward. Now there is high pressure over the Great Lakes, but the high never really does anything. The front stalls in a west to east direction because of this expanding heat dome. It stalls the front and then it begins to push them back northward. So that we can see here by a Sunday night, actually a Saturday night, early Sunday morning, the high is falling apart and the front is stalled, and we actually now getting southwest winds here, and the temperatures are beginning to warm up on the southwest winds, and the heat's going to come roaring back into the mid-Atlantic and east of the Mississippi River for that matter. We can see that here on what the max temperatures are forecast here. This is now for valid 27th of July, which is Monday. You can see mid 90s again in Virginia, North Carolina, and then also across much of the deep south, low to mid 90s. So pretty much south of I-70. I think it's I-70 runs like through here, right across here in this area. That's like I-70. So that's where most of the heat's going to be confined to. All right. Then later on, we get trying to get the second front that's coming southward here. Now this is a Monday, and then this is a Wednesday. So again, another front tries to come south, and it's very slow going here. It's really not doing much. Now a lot of this moisture here in the Gulf of Mexico, this was based upon the 12Z GFS when we just had a tropical depression in the Gulf of Mexico. Obviously, this has become Hannah, so the moisture may be more significant than what the GFS is showing. But you can see the temperatures again. Oops, let me clear this out. There we go. Temperatures again, this is you can see the 26th here, also very warm temperatures again for most of the mid-Atlantic states, the lower Midwest, the deep south here. And then go jump to the right slide here, and then we can see this is now for the 28th of July. Again, look at the heat here in the southeastern states. Very impressive in Virginia, Maryland, and North Carolina. Not so much in the Midwest because this front is pushing its way through. So, and then one of the reasons why the pattern is going to change, or why the heat is going to break, is because of this changes in the jet stream. Now, this is the GFS map here for July 26th, and we can see what's happening, the change here. This big trough in the western United States and the British Columbia is going to end up moving into the mid-Great Lakes area. So this trough here is going to end up going into this area. And we can see what that does is that ends up causing this pattern here. Clear this out. There we go. And then we get to there we go. And we can see that the 26th of July, we can see the patterns here very nicely setting up. This big trough is what's going to do it. Now there's our heat dome, but the heat dome is retrograding and moving to the west, so in that direction, and that's going to allow this trough to become quite big by the time we get to the end of the month. At least that's what the model data is showing. And we can see that here. This is the European model at 120 hours. Look at this. Pretty big trough, and that's a closed upper low north of the Great Lakes, and that's a pretty big trough here. So we have a nice ridge, very nice ridge here, and a pretty nice trough right here. So that really brings in the cool air with the front once it pushes through. In terms of the rainfall, the models are continuing to show pretty good rains here with this cold front coming through. And we can see here, this is the GFS next 5 days. Now, just a lot of hit and miss type of rain here, not much in the next 5 days. The moisture in the Gulf of Mexico, that's all again Hannah. Again, this was before these system became a tropical depression and then a tropical storm. This is the 12Z run. And then then what happens is once that front comes southward, you can see the significant rains in the 6 to 10 day southern Virginia, North Carolina, the deep south areas into Missouri. So you can clearly pretty much see where the front is. This is where the front is approximately, and the front stalls here, which is why you get so much rain in these areas. At least that's what the model is showing here earlier. Now this is the afternoon. Oh, wait a second. There we go. Now this is the morning European. This is the 12Z European model, and again very similar to the GFS. A lot of hit and miss stuff, not a big deal. But then in the 6 to 10 day, the European goes bonkers with the rain and has a lot more rain showing up on these models. And let me show you what that looks like. Now this is the European model from this is from 12Z here on Thursday, and you can see that the Europeans have because the European has such a deep trough here, it's got pretty significant rain. Nice big band of rain here in Iowa, Illinois, Indiana, good for the farm areas, and then this other stalled front here across the deep south. So a very impressive rain here in the 6 to 10 day on the European. Now the European ensemble has that rain more to the south, as you can see, because it's actually even more aggressive with the front than the operational model. And the 18Z GFS actually pushes the rain back up into the northeast because the 18Z has the front not as deep, so the front stalls like this. So we get a lot of moisture coming up from the Gulf, from these tropical systems slamming into the front here, and significant rain. So there's going to be some kind of decent rain here. The issue is, of course, late in the 6 to 10 day going into July 30th, 31st. what's going to happen with these systems here. The other thing that's important to note is the in the 6 to 10 day, the European also has develops an area of low pressure right here, and that low goes right through into Virginia and Kentucky with this front. And that's when you get a low like that in July, in late July, early August, it's always a pretty big rain producer. So we'll see if that actually happens. And then this is the European ensembles here, 234 hours, day 9. And you can see here's our ridge very nicely. The heat dome is now over the southwestern states. And look at this trough. This is pretty darn nice weather pattern here for early August. I've got to tell you, you don't get much better than that. Now, what that does, it also means is that if there's any sort of tropical system threatening the east coast, or the southeastern states, with that sort of trough, it's not going to make landfall if that model data is correct. And then we can see what the temperature difference looks like here. This is the GFS ensemble. We can see that the heat is over now in the southeastern states. I mean, 91 in Richmond, 91 in Raleigh. For early August, that's not particularly hot. And you can see the impressive heat because, again, look where the heat dome is here. Look at the temperatures in the plains, way, way above 100 in these airplanes from the Dakotas down to Texas, Louisiana, Arkansas. So impressive stuff. All right, let's get to our tropics now. This is the 11 p.m. report from the Hurricane Center. There's Hannah, formerly Tropical Depression 8 over here. There's Gonzalo, and there's a new system coming off the African coast. So let's take a look at them. Here's a satellite picture you can see here from late this afternoon, the infrared. Okay, this is Hannah here. And then this system down in here, if you can see this in the blue. Let me try this here. Yeah, you can see a little better there. That's Gonzalo, and there's that other tropical system coming off of Africa. And there's Hannah, in case you didn't see it. Okay, so a lot to talk about here, so let's get right to it. Now, one of the things I want to point out are the ocean water temperatures in the tropical Atlantic. They are extremely warm, as warm, if not warmer, than what we saw in 2017. So the water temperatures relative to normal, over the past 30 years, you can see the climatology here is quite warm. In this area in particular, tropical Atlantic, and then the Southwest Atlantic, also the Caribbean, also quite warm. So this is all sorts of ominous looking development here with these warm temperatures. If you chart it on the graph, you can see that the Eastern Atlantic in particular, off the coast of Africa, look at that, almost a full degree above normal. Well, that's 1 degree Celsius. So it's almost 2 degrees Fahrenheit above normal. So it's pretty darn warm in the Eastern Atlantic Ocean. All right, now this is our dust cloud here. We can see this here from the CIMS folks here in the University of Wisconsin. And again, there's our systems. There's Hannah looking very nicely as a tropical storm. There is teeny wee Gonzalo, which is really small. And then there's that big tropical wave off the coast. Now, here's the dust. You can see the dust is very impressive here, but it's not nearly as strong in the central Atlantic, and that's kind of decent. And of course, notice that Gonzalo is south of the dust and staying in that way where there's not much dust in the Caribbean. And then this system is also staying pretty far to the south. So that's also, if that's true, this dust cloud here is not going to have much of an impact. And that's kind of a big change from what we've been seeing. That's not unusual. Usually we see this sort of breakdown of the dust cloud in July and late July and early August. That's why the tropical Atlantic, the Cape Verde season kicks in, because the dust begins to break down, but it's still nice to see nonetheless. The MJO here, we can't use that to forecast anything because as you can see here, we have the Canadian model in the lower left, the Japanese model here, the European. They have it in phase 2 and then it moves into the neutral circle pretty much in all these models as we go into the end of July, first week of August. So that really does, so the MJO is not really a factor. As it's heading into the neutral, it's weak, it's heading into the neutral circle, it's not going to be a factor. So, we can't use that to determine if there's going to be active hurricane cycle here or not. Obviously, we've got a lot of activity. We really don't need to know that. So, but the MJO is not really helpful at this point. Now, let's take a look at our 200 millibar velocity potential anomalies, the VPAs. And again, in case you don't know how this works, and I'm sure many of you don't, we're looking for here, this is green. This represents rising motion. So when you have rising motion in the atmosphere, okay, you have convergence at the surface. So you get low pressure and it gets evacuated up, the air goes up the column, and you start getting spinning motion and it creates storms. So green means rising motion, convergence at the surface. Brown means sinking motion, okay, and subsidence, so suppresses storm development. So this was, if you recall, July 20th. Now this is when we had Douglas begin to form. Now, of course, Douglas is going to be a hurricane, and it's probably going to threaten Hawaii at some point. But when it developed in the eastern Atlantic, you see the green stuff here? There you go. So this was favorable for development back on July 20th. Now this is the new one, July 23rd, and this green stuff, all this is moving from west to east. So the green activity, enhanced activity, is now moving into Brazil, the Caribbean Basin, and the tropical Atlantic a little bit. And now we're getting a kind of sinking motion, weak sinking motion here in the Central Pacific. But, I mean, it's not enough to stop Douglas, but it is enough to make sure it's probably not going to intensify too much more. Interestingly enough, we have a lot of green here in the Indian Ocean, which means more activity here for tropical equatorial Atlantic. So that's going to keep the Cape Verde hurricane season humming, it looks like. Now, if we look into the future here, this is the European ensemble for the next 5 days. And again, look at all the sinking motion in the Atlantic Ocean here, I mean, in the Central Pacific. Very strong sinking air here, not a lot of tropical activity the next 5 days. But we can see the green, light to moderate green color here in the tropical Atlantic and the Caribbean. This would favor Gonzalo and the tropical systems come off the coast of Africa for some sort of development. And also look at the enhanced green here in Africa as well, Eastern Africa. The GFS ensemble for the next 7 days kind of agrees with that. You can see it's got the big brown area, but notice it's further to the east. Here it's in the Central Pacific. Here it's close to the west. It's off the coast of Baja in the Eastern Pacific. And notice that the tropical Atlantic is neutral. It's not green, it's not orange or brown, it's neutral water conditions here. So bit of a discrepancy there. And then the European 6 to 10 day, we can see that the green stuff here continues to be pretty strong off the coast of Africa, and then a lot of activity in the Cape Verde across equatorial Africa here, which would potentially mean a very active start to the Cape Verde hurricane season. And all of Africa looks really, really wet and very active here. And if we look at the GFS ensemble for the week 2, we can see pretty good activity again, even in Africa. Look at all the green stuff here. This is Southwest Africa where you get your tropical waves coming off. Notice that the tropical Atlantic is neutral here. And then Africa is very, very active here. A lot of energy in the Indian Ocean and Africa. Now we do have a lot of sinking coming into the Caribbean Basin. Well, Eastern Pacific, it looks like it's coming into the Caribbean Basin here a little bit. So we'll have to see if that's true or not. This is much more aggressive with this whole brown sinking stuff than what the European ensemble is showing. Okay. Let's take a look at our steering currents. Now this is the low level winds because these systems are weak. We don't have hurricanes here. So we're using 700, 800, 850 millibars. And notice the flow here. There's our big Bermuda high. You can clearly see that right here. There's the big Bermuda high. Okay, and look at the flow. The flow is straight like this. That means that Gonzalo is going to pass due west to east and very close to the north coast of Venezuela. South America. It may pick up a little bit of latitude, but I don't think much. And then this, of course, is Hannah, and it's headed in this direction here. So I want to show that to you. And that's important because this area of the Caribbean, right in here, let me call it my marker, in the Southeast Caribbean is a dead zone. Systems come into here and they pull in a lot of dry air from off of Colombia and Venezuela, and this gets wrapped up into the systems, and they end up dying or falling apart in the eastern or southeastern Caribbean. So that's not showing up on a lot of the hurricane models, and the Hurricane Center has ignored it. But I think they're making a mistake ignoring this possibility. All right, this is the visual picture from this afternoon from Hannah. You can see very impressive looking system in the Gulf of Mexico. And if it would stay out there for a couple of more days, it could become quite a system. Here's the satellite picture from, again, this is from this afternoon around 4 or 5 o'clock. A real big burst of intense convection there around the center. A lot of cyclonic curvature, nicely developing system. At the time, this was a tropical depression. This was a satellite recon from this afternoon. You can see the flight level winds. Again, looking at the blue color here, notice top around 30 knots. That's it. So mostly tropical depression strength. You can see the pressure as well. Again, the pressure dropping. You can see here around 1,008, 1,009. Not a big deal. And then, but the system continued to intensify. And this was the evening satellite picture. It looks like it's trying to form some sort of eye or closed low-level circulation. And you can see I don't know if that's an eye or not. I'm still trying to figure that out, or whether that's just a hole in the infrared picture. But it is definitely intensifying, and we can see that because the data showed that it is intensifying. You can see the new flight level winds from the recon up to 35 knots, surface winds up to 40 knots. The surface winds 35 knots. The pressure has also dropped down to around 1,003, the lowest point. So it definitely was intensifying here, and that's why it was upgraded. And this here is the official forecast track. You can see it's into southern Texas. It's a tropical storm, not a big deal. Most of the models are doing that as well. It's not a complicated system. This forecast is pretty easy. Now, this is the official track here for Gonzalo. And again, they have it gaining latitude as it approaches Barbados and Trinidad. And okay, as a hurricane, maybe. But then you can see the weakened tropical storm strength as it, because of the interaction here with the southeast coast in the southeast Caribbean off the coast of Venezuela. That's a real problem for these systems. What happens is they pull in a lot of dry air that gets entrained into them, and it causes weakening, or at least structural weakening, if not actual breaking apart of the wind field and causing the mean sea level pressure to rise. So, you know, I think a lot of people are overlooking that. This is not a good track for the system to survive. Now, once it gets into the central Caribbean, it's much better, but we'll see. So I think that's being overlooked now. Again, most of the models are showing this west northwest track, so it just clears the coast. I mean, it has to go west northwest. If it was going due west right now, it would crash into the north coast of Venezuela. So the west northwest track is fine, but again, it's very very close to that coast of with Venezuela. Intensity, you can see it's gaining a little bit of intensity here, becoming a minimal hurricane in a lot of the models, but not all of them, and then it falls apart. And a lot of the models show the system dying. They weaken it in the central and western Caribbean. If you look at it relative to the dust, you can see that it is south of the dust cloud here. So that's a good sign. I don't think you have to worry about dust with the system here, but it is tiny. I mean, there's a very small system here. I mean, I have zits in my ass which are bigger than this thing. It's a tiny, tiny system. It's developing nicely, but it's very small. Okay, and then finally, let's take a look at the system coming off the African coast here. This very impressive tropical wave here, and it does show some potential for development. Now, down the road, the European model develops this into a significant or major hurricane, maybe Category 3, or at least a 2, borderline 3, approaching the eastern Bahamas at day 10. You can see that very nicely. And that shows up on the European ensembles to some degree. The European ensembles are showing a high probability of some sort of tropical system in the northeast Leeward Islands. So, and of course, this here is the high pressure area. So, if what would have to happen is that this would have to get around the high pressure system here. And there is weakness in the western flank, so maybe that could happen. Again, this is a long way out. I'm not going to give any sort of alarm here, but we'll see how this develops. It's got possibilities, is what I'm trying to say here. Now, the other thing to notice is this: we talked about Africa here, the amount of energy and waves on the African coast. The rainy season here in Southwest Africa is just off the charts. This is total rainfall since July 1st. And you can see Southwest Africa, very, very wet. Large areas of 100 to 300 millimeters. That's anywhere from 4 to as much as 12 inches of rain in a lot of these places. And that's way off the charts with the anomalies. Look at these anomalies. Very, very impressive for a wet July. And ominous looking concerns here for the heart of the hurricane season and the Cape Verde season in particular in August and September. This is very not good, is what I'm trying to say here. And this is the satellite picture which shows you what's going on in Africa, which is why they're getting all this damn rain. Look at these systems coming across from the eastern Africa, Indian Ocean. Look at these bombs. Okay, this here is the current system right there. Well, let me see if this lines up better with this one. No, there you go. That's the current system here. And then look at this one, and look at this one, and then look at this over here. I'm telling you, this has got to be, we get into the heart of the hurricane season, Cape Verde season. Africa, the stuff coming off Africa is going to be damn busy. This is meteorologist DT from Weather Risk. I'll see you on the Facebook page and on the Twitter page.